Alright, today's video is on the Pythagorean theorem. Before we get started, however, we need to go over the format of the notes. Some of you might be familiar with this format. It's called the Cornell notes. What you'll notice is up here we have the topic. Over here is information on you that I want you to fill out. Then they have the essential question in this section right here. And then you have a place for the notes, and then you also have a place for questions. Down here is the summary. So this is the format I'm going to want you to use for most of the times that you're taking notes, and that way just keep that in mind for the future. Okay, today's topic is understanding the Pythagorean theorem, also known as a squared plus b squared equals c squared. By the end of the video, you'll understand this equation. Our essential question is this: given the length of the two sides of a right triangle, how can I calculate the length of the missing side? By the end of this video, you should be able to answer that question. First, what we want to do is look at the parts of a right triangle. And we know what makes a right triangle. It's a 90-degree angle. So right here we have a 90-degree angle, and like I said, that's what makes it a right triangle. Now the two sides that form the right angle, that is this side and this side, they have a special name. They are called the legs of the triangle. So this is a leg, and this is a leg. Now the hypotenuse is the longest side of a right triangle. It's the longest side of a right triangle. It's the side that is opposite the right angle. So therefore, this side right here is the hypotenuse. Notice it's opposite from where the right triangle is. So it's basically, there's two ways that you can identify the hypotenuse. It's the longest side, and also it's the side that's opposite the right angle. Now what I'd like you to do is identify the legs and the hypotenuse of the following right angles. All of these are right angles. So what we need to do is label the legs A or B and label the hypotenuse C. It doesn't matter which leg is labeled A and which is labeled B, but the hypotenuse must always be labeled C. So let's just do this first one together. We can have this, designate this as side A, this side B, and this is C, the hypotenuse. And we know that it's the longest, and it's also opposite of the right angle. Now, pause the video and identify the hypotenuse and the legs for the rest of the triangles, and when you're finished, restart. Okay, check your work. I hope you got them all correct. As I mentioned before, the A and the B do not matter. They're interchangeable. But the C's must be in the same place that I've marked the C's. So if you got the C's in the right place, then I'm sure you did fine. Okay, now that we've got the parts of a triangle down, we can move on to the Pythagorean theorem. Now, over 2,000 years ago, there was a Greek mathematician named Pythagoras who discovered a special relationship between the three sides of a right triangle. What he discovered is this equation right here. Let's try that again. A squared plus b squared equals c squared, where A is the length of the side of one of the legs, B is the length of the side of the other leg, and C is the length of the side of the hypotenuse. Now, if you take this side A, square it, and add it to side B, square it, it will equal side C squared. So let's take a look at some examples of this. Okay, we're told up front that these are right triangles. So if we're given some additional information, if they tell us the lengths of the two legs on this first triangle, we can figure out what the length is on the hypotenuse. So let's say that this side is 3 units. Let's say that this side is 4 units. And the hypotenuse, well, that's what we're looking for. We don't know at this point, so we'll just go ahead and call that x. Now remember, our formula is a squared plus b squared is equal to c squared. So what we'll do is we'll substitute the a and the b for the parts that we know. We'll say that a is 3, and we'll say that the b is 4. And instead of putting c, we'll go ahead and put the x here, but it'll be x squared. So 3 squared, continue to work here, we'll have 9 plus 16 is equal to x squared. Now we follow through, that'll be 25, 9 plus 16 is 25, is equal to x squared. But I don't want to know what x squared is, I want to know what x is. So the way I would find out what x is I would have to find out what the square root of x squared is. And that's fine as long as I do the same thing to the other side. I need to find out what's the square root of 25. And the square root of x squared is x, and the square root of 25 is 5. So now I know the length of this side is 5 units. So that's a great way to figure out what the length of the hypotenuse is by using this formula. Okay, let's do another one. Remember, it's always smart to go ahead and write down your formula. So once again, we have a squared plus b squared equals c squared, and we will substitute the 6 for the a. We'll substitute 8 for the b, and we'll go ahead and call this x squared. So 6 squared is 36, 8 squared is 64, is equal to x squared, and if we add these two together we'll get 100 is equal to x squared. If we find out the square root of both of these, the square root of 100 is 10, and the square root of x squared is x. So we found out the length of the hypotenuse is 10 units. Okay, now let's do one that's a little bit different. Instead of being given the length of the two legs and finding out the hypotenuse, what we're going to do is we've been given the length of the hypotenuse and one of the legs, and what we want to do is find out the side length of the additional leg. Let me fix this pin here. Okay, I think this is going to work a little bit better. Now, we still use the same formula. So the formula is still a squared plus b squared is equal to c squared. The formula doesn't change. So let's go ahead and substitute 12 for a, and now b we do not know. That's what the unknown is this time. And c squared, we do know. It's going to be 15 squared. Let's move this over just a little. All right. Now, we know that 12 squared is 144. We don't know what b squared is. And we know that if 15 squared, if you have a calculator, figure it out, punch it in, but I believe it's 225. So All we have to do to figure out what the b squared is move this 144, subtract 144 from both sides, and what we're going to end up with is b squared is equal to, so b squared is equal to 81. And once again, what we want to do is we want to find out what's the square root of b squared, and we know that's going to be b, and what's the square root of 81, and in this case, of course, it is 9. So we've just found out the length of the unknown side is 9. If I can write it a little bit neater, 9 units. So it works the same way. You're just looking for that unknown side. Let's go ahead and finish off our notes. The Pythagorean theorem describes the relationship between the length of the hypotenuse and the length of the legs. Once again, a squared plus b squared is equal to c squared. And we can use the Pythagorean theorem to find the missing side of a right triangle if we know the length of the two other sides. Now there'll be more notes on this, but we've got the main ideas down. I hope you learned something. I hope you watch this and are able to come in and start doing problems with the Pythagorean theorem. Thanks for watching.